Hello everyone. Let's take a look in this video at how we can calculate the circumference and area of a circle. Area is a term that you're probably obviously familiar with. This idea of circumference might be something new to you. So let's jump right in, and first we need to take a look at a few definitions before we can start looking at formulas for circumference and area. We need to define a few terms. To start with, we need to define what exactly a circle is. We can probably recognize that a circle, it's that round shape, right? But what is this? What is the actual technical definition of a circle? Well, a circle is the set of all points in a plane that are the same distance from a given point called the center of the circle. So to kind of break this down, first of all, we're looking at a set of points in a plane. Now, a plane is kind of like a piece of paper. So if you can imagine that you put a dot on a piece of paper, and then you pick some distance that you want to measure away from that dot. So let's kind of represent that. We're going to measure a distance of about like this. And we're going to find every place on this piece of paper that would be this distance away from this one dot that I've picked out. So I might put a dot, let's see, I'll use an orangish color. I might put a dot right there, right? And then if I went the other direction, I would have another dot here. And if I went straight down from my original dot, that same distance, I would have one here, and I'd have one here. And then if I started going in every conceivable direction from my original dot, my original point, and I started measuring out that same distance in every possible direction from my original point, you can see that's going to start looking like a circle. As I fill in all these spaces between the points that I've already measured out, I start getting something that looks an awful lot like a circle, right? So we can kind of understand where this definition of circle comes from. As I fill in all of these spaces, I would have that shape that we recognize as a circle. So it's the set of all points in a plane that are the same distance away from a given point that we're going to call the center of the circle. The second definition that we need to know has to do with a part of a circle or a measurement within a circle. If I measure the distance from the center of a circle, so if I look down here at this diagram that I have where C is like my center, I picked C for center. So here's my center. If I measure the distance from that center to some point that is on the circle, like point D, this distance right here from C to D is called the radius of the circle. And radius is usually just going to be represented with that lowercase r. So this is the radius of my circle that has a center at C. If I want to measure the distance all the way across the circle, so in other words, if I wanted to measure how far it is from A to this point B that is directly across the circle, I'm going to go, when I measure that distance, I'll end up going through the center of my circle, right? If I measure this distance, I'm going to go through the center of my circle. That distance or that segment that connects those 2 points that are directly opposite each other in the circle, that is going to be called, so let me fill in that word, the distance across the circle through the center, that's going to be called the diameter of the circle. All right, so we have a radius that goes from the center out to the edge of the circle, and a diameter, so if I wanted to kind of label this in my picture, this segment here, segment AB, which represents the distance from A to the point that's directly opposite the point A on the circle, point B. That's the diameter of the circle. Now there's a relationship here between the radius and the diameter. Some of you guys might be kind of picking that out, right? If I look at a diameter, it's kind of made up of two radiuses stacked end to end, or two radii stacked end to end, right? From C to A would be a radius, and then from C to B would be another radius. So the diameter of a circle is equal to 2 times the radius. Or another way to think of that is that the radius of a circle is half of the diameter of the circle. And so that's a relationship you might want to keep in mind, because There might be some problems where you need to use the radius of the circle, but you're given the diameter. So you need to realize that if you know the diameter but you want to know the radius, all you got to do is take half of the diameter to get the radius of the circle. So keep that in mind. Last term that you need to know is something called the circumference of a circle. The circumference of a circle is the distance around the circle. So if I measured from A, going clockwise around this circle until I got back to A, that would be the circumference of the circle. It's kind of related to the idea of a perimeter of a polygon. Remember, if we wanted to find the perimeter of a shape like this, I would just add all these lengths and widths together. In other words, I'd figure out what's the distance around the shape. That's the same idea with circumference. It's kind of like the perimeter of a circle, if you want to think of it that way. Now, there's an interesting relationship between the circumference of a circle and its diameter. It was discovered hundreds of years ago. Mathematicians hundreds of years ago realized that if you took, like, for instance, if you took a string that was of equal length of the diameter of a circle, so a string that was as long as the diameter of a circle, and you started wrapping that string around the circle, well, first of all, you would need more than one string of that length, because one string that's as long as the diameter of a circle would only get you about 1/3 of the way around the circle. Then if you got another one, you'd go another 1/3 of the way around the circle, about, and then you would need another one, and you wouldn't quite get all the way around. So in other words, if I took strings, to kind of visualize this, if I took a string that was as long as AB is here in this, it might get me around to about here. And then I'd take another one, and I'd get around to maybe about there. And then I'd take another string that same length, and it would get me almost back to where I started, but I would need a little bit more. In other words, I'd need a little bit more than 3 diameters to go all the way around a circle. In fact, I would need about 3.14 diameters to get all the way around the circle. And this number 3.14 probably sounds familiar to you, right? And it comes from this idea that if you take the circumference of a circle and you divide it by the diameters, in other words, you figure out how many diameters does it take to go all the way around a circle, the number you end up with is a number that we call pi. And pi is an irrational number. That means it has a decimal number that keeps going on forever and ever and ever, never repeats, and it never terminates. 3.1415, blah, 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 blah. It keeps going. But sometimes we kind of round it off as 3.14. So this idea of pi comes from the fact that it takes a little more than 3 diameters to go around a circle. But from this relationship, we end up with a couple formulas. The circumference of a circle can actually be calculated by taking that pi and multiplying it times the diameter of a circle. So in other words, if I knew that the diameter of this circle from here over to here, let's say I knew that was 10 units, then the circumference of that circle would be pi times 10. And so I would grab my calculator and I would take pi times 10, and it's going to give me, when I do that on my calculator, you're going to want to use pi, don't use 3.14, take pi times 10 and you're going to get a big long decimal answer. It'll say 31.41592654, and it might even go further than that depending on what kind of calculator you have. We're going to round that off, so we'll say it's about equal to 31.4 units. So if the diameter of my circle was 10, then the circumference would be 10 times pi, which is about 31.4. Now there's another formula for a circumference of a circle that you might want to know, and it uses this idea that the diameter of a circle is equal to 2 times pi. So if I replace this diameter with a 2, I said 2 pi, I meant 2 times radius. If I replace this diameter with 2r and kind of rearrange that a little bit, I would get this other formula for circumference, which is 2 times pi times the radius, or 2 pi r. And you can see that in this picture, if my diameter was 10, then my radius would be 5. So if I was calculating the circumference using that radius measurement, it would be 2 times pi times 5, which is still going to be 10 times pi, right? It would be essentially the same calculation that I'd be making. And so I would still get about 31.4. Now the area of a circle, there's a different formula we're going to use for the area of a circle, and it is that the area is equal to pi times the radius squared. Remember, squared means times itself. So in this diagram up here, using this measurement of 10 for the radius, 10 for the diameter, or 5 for the radius, then the area of this circle would be pi times 5 squared. 5 squared, remember, is 5 times 5. So here we're talking about pi times 5 times 5, which is pi times 25. So if I grabbed my calculator and I quickly typed in 25 times pi, I'm going to get an answer of about 78.5 units squared. If I was measuring this, so let's say I was measuring this in inches, then my unit would be inches squared for the area of that circle, 78.5 inches squared. So one more example that I want to show you, and that's how would I find the radius of a circle if I know its area. If I know its area is 380 square feet, then what would be the radius of this circle? And the way I'm going to do that is I'm going to start by writing my formula for area of a circle. Area equals pi r squared. Then I'm going to fill in for the area, I'm going to fill in what I know, that it's 380. And that leaves me with pi r squared on this side. So I have 380 equals pi r squared. Now what I'm trying to do is isolate this r, get this r by itself. So what I need to do first is get rid of the pi that's in front of it. Now remember, pi is a number, which means I can divide by pi on both sides. That's going to eliminate the pi on the right side of my equation, and I'll just have r squared. When I take 380 divided by pi on my calculator, what I should get is about 121. So now I know, I'm going to come over here and rewrite this. I know that 121 is the square of my radius. It's r squared. So to get the r by itself, I need to get rid of this squared right here. I need to get that out of there. I don't divide this by 2. What I do is I do the square root of both sides. The square root of r squared just leaves me with r. The square root of 121 is 11. So the radius of this circle that has an area of 380 square feet, the radius would be 11 feet. So hopefully you understand a little bit now about circles and a couple of the terms that we're going to use when we are talking about circles. You hopefully know a couple different ways you can find the circumference of a circle, depending on whether you know the diameter or the radius of the circle. And you should be able to also find the area of a circle using its radius. So we'll see you next time in the next video, and good luck with any kind of homework that you have to do.